In this tutorial, we're going to cover an introduction to OpenCV again. So the methods of the OpenCV components are going to look very similar, but this time we're not relying on GH-Python remote to do the socket connection. Instead, we're going to custom build our socketed connection from inside of Rhino to connect to OpenCV in our PowerShell. This will allow us to run any OpenCV or just any modules or libraries we want to access from inside of Rhino that exist outside of Rhino through our socket connection from Grasshopper to this terminal. The first thing I want to do is just show you some examples. This is going to look very similar to our examples for the GH-Python remote video. So inside of our Grasshopper file, day 4 intro to sockets OpenCV, it looks incredibly simple. There's only one component here. That's because we don't actually need to do much inside of Grasshopper. All we're feeding in is a path to our reference image. And inside of this component, we actually only have a few lines of code that are just opening up the connection to our socket and sending that encoded path information to our Python code, which reads that data in and then runs the OpenCV operation. So the first thing to do in this case is to open our PowerShell. So I have my PowerShell here, and I've already changed my directory here to the directory that I want to be using. This is going to be the example folders directory, but in case you don't have that already, if you just copy the path to that directory with all of these Python files in it, and then just type cd for change directory, space, and then paste that path, we've now changed our directory to that path. We can then hit CLS to clear the above information to keep our terminal clear. And now we can type ls to list the items in our directory. So this just helps so that we can actually read out which Python files we have in this example folder. And we're just going to go through one by one and show demonstrations of these, very similar to what we did in the GH-Python remote tutorial. So the first one is Python. I'll just go in order in this case since we've already seen these methods once in the previous video. So Python, and then type the name of your Python file. So this is going to tell the terminal to use Python to open the following file. So cv_canny.py, and then hit enter. It's going to prompt us in this terminal to run GH component to run OpenCV. So I'm actually going to just move the Rhino window over here and then shrink our Grasshopper window so that we can actually see both of these at the same time. So now we just need to click on this reset button. It actually just timed out. So if we just arrow up in our terminal, we can access that command again, Python cv_canny.py. So hit that again, enter. It says run GH component. So now inside of Grasshopper, just click on this button, and we can see our window from OpenCV open with our Canny edges open. Now we can do this with each file. So I'm going to skip Python not color swap, because in this case we're only inputting one image. So we're just going to skip that and go to the contour method. So cd contour, and then hit the button to run that method. Now the next one is Python cv crop. And again, we need to hit our reset inside of Grasshopper, and we can see a cropped image resulting. Now it's Python cv grayscale, and we get our grayscale image. Then resize, we have our resized stretched image. And now rotate, we have our rotated image rotated clockwise 90 degrees. And then the last one is threshold, so cv threshold.py, and then click the button to run that, and we can see our adaptive threshold output in our window. Now I'm going to type CLS inside of the terminal to just clear all of that up, and we can start by going into Grasshopper, and we're going to just go through how to set up our socket connection. So if we just double click in the canvas and type GH-Python script, and we can rename this to send socket. We don't need any outputs because we're just feeding information to our socket and connecting to the terminal and then running it there. So we won't actually be getting any information back into Grasshopper. Then we need an I input for our path. We can double click and type path, select file path and plug that in. And then we need an R just as our gate to tell whether or not to run this component. Make a button. We can plug this in. So our button again is going to be false until it's clicked, and then it will be true, and we can run this component. Now, if we double click into this component, we won't actually be needing Rhino script as we're not operating with Rhino geometry right now. But what we will need is a few additional libraries. The first one is going to be our socket, so import socket. And then we need to say from socket, import af_inet. I'm not going to go too much into detail into the specifics of sockets in this video, but if you have questions, please feel free to reach out to me and I can answer them on a case-by-case basis. Next, from socket, so this is going to be from that library, import all caps sock_stream. So we're importing those two from our socket library, and then enter if r, and this will provide us our gate. So it'll only happen when that button is selected. Now, when building connections for sockets, we first need to describe our host. And this is going to be our local host address. And this local host is actually going to be the same for everyone. So we're going to use this local host here. If you are interested in reading more about this, then check out some of this documentation. But it just says localhost is a host name that refers to the current device used to access it. It is used to access the network services that are running on the host via the loopback network interface. So this just allows us to connect to our local host and then specify specific ports, which we'll do next, and that will allow us to connect outside of Rhino. So we can just paste that in there. So 127.0.0.1 is our local host. And then we are going to set a port, which is just going to be an integer. In this case, it is 8080. And now we just need to do a few things for our file input. So first, we want to make sure that our file path is a string in case we're not feeding it a string inside of Grasshopper. So this will just convert it to a string so that we make sure that's a file path. We could also do a check whether that file actually exists here, but for now, we will just hope we're properly inputting a file path. And now we need to encode it. So path_byte is going to convert that string into bytes so that we can send it through the socket. Path byte equals file path.encode, and open and close parentheses to call that method encode. The next thing is to actually build the socket and then connect to it. So we're going to call this s and set s equal to socket.socket. And we are going to feed in a family and a type. So we have this up here, so we can feed in socket.af inet, and then socket.sockstream. So after we've actually built the socket, we need to connect to it, and then we need to send our data. So we need to say s.connect, and we need to tell it which port and what IP to connect to. So we're using our local host, and our port is 880. And now we need to actually send the data. So this connects, and now we need to send. So we just type s.send and send our path byte. Now that's all for the Grasshopper setup, and all this is doing is taking our path information, converting it to a string, encoding it into bytes, and then sending that information to the socket. If we click run, nothing actually happens, and in fact, we would get an error, and this is because the stream is closed, so there's not actually an open stream to connect to. So we're going to establish that open stream inside of a Python file running from our terminal. So if we minimize Grasshopper, for this step, we want to go back to our terminal, and if we are in our example folder, that should be fine. I'm going to just create a new example Python file that we're going to build and run together in this video, but it should look like any of the example files. We're just going to go through one OpenCV method though, since we've already covered a few of those in the previous video. Now, inside of this terminal, if we have Visual Studio Code installed, which you should all install Visual Studio Code. This is going to be our main text editor to edit Python scripts in outside of Rhino. What we can do is actually type code, so CODE space, and then the name of a new file with an extension to specify what type of file that is. So I'm going to say example.py, or we could even say, just to be specific, cv example.py, enter. This is going to open up Visual Studio Code, which it did, and it's going to open a new file called cv_example.py and save that file directly to wherever our directory is. So in this case, it's our example folder. Now, this text editor may look different than the Python script editor in Rhino, but it's going to operate very similarly. This is just operating in CPython instead of IronPython like Rhino. But the general structure is still to import libraries, and then if we need to build a function or build a class, do that, and then call those. So it has a very similar structure. It's still Python. So the first thing to do is going to be import our library, which we are going to need to import CV2. So import OpenCV, import socket, import OS just in case, which is our operating system. And then we can also import Numpy as NP in case we need to use Numpy for any array mathematics or transformation. Next, we want to build our function. So we're going to call this function def and then server. And we don't need to feed anything into this, but then underneath this server, inside of the function, we need to define our server and specify our host address. So that's 127.0.0.1. And now we need to say, slightly different than our Rhino component, we need to say with socket.socket, and then same inputs here like in Rhino. So socket.af inet socket.sock string. And then we're just going to give this a nickname as well, so as s. So while that socket is connected, we're going to use the method bind and feed in our host and our port. In this case, we can either define our port here, so equals 880. This is going to be the same port that we are going to read from Grasshopper. So we're sending it to that port from Grasshopper. We need to read the same one in our terminal. If we don't want this to just connect and then sit there, usually what we'll do is actually add a timeout feature. So set.timeout, s.setTimeout, and then we can feed in here an integer, and this is going to be the number of seconds that the connection will wait and stay open with nothing actually happening. So we can just give it a value of 20. So after 20 seconds, that connection is going to close. That should be good, but you can adjust that later on as needed. It's just a kind of extra check to make sure it's just not sitting there open forever. Now we can give ourselves a note, which will appear in the terminal when this is ready and connected to run our Grasshopper component. So print open parentheses, and we need the parentheses inside of CPython outside of Rhino. So print open parentheses, and then just give it a message. This is just to yourself, so you can say whatever, but you can say run th component. Now we need something that actually gets the information from our connection. So we can make a variable file path, set this equal to a function. So in this case, we can say get data from socket. We need to now define this function at the top. So we can hit enter a few times, type def, and then paste, enter. Inside of this function, we need to pass in our socket. Then we need to listen for our connection, then accept that connection, and then with that connection, so with con open, with that connection accepted, we need to receive our data. So return_byte equals con dot receive, and then we can pass in bytes to receive. So in this case, 1024 is just a kind of catch-all value there. Now we need to convert this byte to a string. So we will make a variable return_string equals return_byte dot decode. And this is going to convert the information from bytes to strings. And now we need to just return string. So this will pass it out and set file path equal to that information. Now, when we call this function here, we haven't passed anything, but we know we need a socket. So we can just feed in s, and that will pass in the socket to that function. Now, everything after here is just going to be our OpenCV methods. So we can just kind of block out space here and say place OpenCV methods here. So that's just a note for ourselves that we can do all of the OpenCV methods using this file path here. So the first thing we can do is say image equals cv2.imRead and feed in file path. Now we just want to choose any of our methods. So let's say gray equals cv2.convertColor, feed in the image, and then the color space, which is cv2.color_RGB to gray. Now we have our grayscale image, and if we want to show this, it's the same as our previous methods that we saw in using GH-Python remote. We just want to say cv2.imShow. This is going to take a title if we want, so we can say grayscale, and then feed in our gray image. If we want to show both our original and our grayscale image, then we just want to say original and feed in our image input. And now, to make sure these don't run on forever, we need a cv2.wait, and we can feed in 0, and then we need cv2.destroy all windows. And if we copy that and paste it after our grayscale image as well, in line with all of these others in the tab, then we will be able to hit a key to destroy our original image, and then it will show our grayscale, and we can hit a key to destroy that one, and then it will close and end the method. Now, the one last thing we want to do is actually just call this function here. So copy server, and we can have a conditional that says if __name __. So if this name equals main, which just means if we're directly calling this Python file, which in the previous examples that I displayed in the terminal, we were directly calling these Python files versus referring to them in another Python file. So this is just a condition that is helpful in most cases if we only want to run the information inside this Python file from a direct call to it from our terminal. So then inside of here, we can just say server, open parentheses, close parentheses, and then hit Control S to save. Now this should work. So if we go back to our terminal, we can just type Python. So we are using Python to run the file cv_example.py, which we just made. And then if we hit enter, it says run GH component. We can go back to Grasshopper and click our new component that we just made in this tutorial video. So click on that button. And we see our original image here. We can then hit any key or hit enter, and we now see our grayscale image. That's going to be it for our introduction to OpenCV with sockets. This just allows us to now not rely on GH-Python remote, but we can actually use any Python file outside of Rhino, connect to it, pass data back and forth. So we're only right now passing from Grasshopper, but we can actually do a similar setup where we read in data into Grasshopper and construct a loop passing back and forth from Rhino into our terminal and then back. In the next video, we're going over the construction of a 2D agent that is actually going to use these OpenCV methods in order to trace specific edges and details or features of an image. So this is going to be a kind of image-driven or image feature-driven 2D agent.